As we specify the utility maximization problem mathematically, we typically leave out a constraint that we simply take as given. That constraint is that the consumer cannot consume a negative quantity of any of the goods. From an economic standpoint, this makes perfect intuitive sense. You can't consume negative quantities. From a mathematical standpoint, however, we would technically have to specify this in the problem. For most of our applications, we won't have to, because the solution will automatically be one that is what we've called an interior solution. However, sometimes, as we've seen, we will encounter corner solutions, and we have to be careful as we solve through the math to pick those up as we go along. Consider, for instance, a problem that graphically solves to a corner solution, a problem where, for instance, tastes are quasi-linear, and bundle A on the horizontal axis is the best bundle that a consumer can buy. In panel B, we replicate this graph exactly, except that we now extend the vertical axis into the negative dimension. When we solve this problem mathematically, the math will look for a tangency between an indifference curve and the budget line, and the tangency that it will find will be a tangency between the extended budget line and the magenta indifference curve that we've drawn here. The math will therefore pick out bundle B as the optimal bundle for this consumer. In other words, the math, by searching for a tangency between an indifference curve and the extended budget line, will have us believe that the consumer will do the best she can by consuming 12.5 units of X1 and minus 5 units of X2. From an economic standpoint, this makes no sense. The consumer cannot consume a negative quantity of X2. The correct solution is the corner solution A, where the consumer consumes 10 units of X1 and no units of X2. However, at that point, the blue indifference curve technically crosses the budget constraint, or at least the extended budget constraint, which is why the math does not pick up that solution as the correct solution. There are indeed more complicated ways of specifying the mathematical problem, ways that would explicitly add constraints that specify that consumers cannot consume negative quantities of goods. There are also solution methods for solving those more complicated problems. The solution method for this problem would be called the Kuhn-Tucker method. The good news, however, is that we don't have to bother with these methods here. Rather, we can simply use our common sense. If we solve a mathematical problem, and the math tells us that a consumer will optimally consume a negative quantity of a good, we know that we've in fact reached the corner solution, and we can then use our intuition to conclude what that corner solution must in fact be.